Welcome back, everyone, for another episode of Data Analytics Chat, where we discuss the challenges and latest trends in the vibrant world of data science and AI. Today, we've got an exciting topic, and we will be looking at how to do data engineering. It's obviously a big, important topic for a lot of companies, and I guess a lot of their efforts are getting pushed that way nowadays with the recent changes and advancements in technologies. So today, I'm delighted to welcome Samit Korgaonkar, who is the head of engineering for enterprise data at Google. Welcome, Samit.
Hey Ben, thanks for having me here. Excited for this conversation. Uh,
So what I'll do is get it. Yeah, can you just introduce yourself?
sure, Samit Korgaonkar. I'm basically been working in the data and analytics space for almost 25 years now. I primarily focused on working on engineering solutions to unlock the potential and creating competitive advantages for driving business transformation. And I've worked in multiple large corporations, Google, Morgan Stanley, Merrill Lynch, IBM, and few others, where my focus has been, centered towards developing and executing data strategies that empower business to make informed decisions and thrive in this changing landscape. I think it's been, like you said, in a pretty exciting space that's been evolving over time. I continue to look for opportunities to learn and expand my knowledge in this space, but happy to share my learning so far in this conversation.
Yeah, good. I mean, it's just a massive subject, isn't it? Really. I read. I think not. I think 95% of businesses say that managing unstructured data is one of the biggest problems for their business.
I would say structured and unstructured. Both tend to, unstructured is the newer type that's coming to the market, but I do feel companies still also see challenges and struggles managing structured data as well. So though it seems like a problem from the past, I've seen it enough that I feel that's a challenge that people continue to. I think what has changed is the industry has changed where that's become a very critical part. It's no longer a side tech function. I think people are looking at how can I leverage that the data that I have for competitive advantage, getting into new businesses, looking at new opportunities. That's where I think a lot more focus has got into this space, which has been pretty exciting.
No, it's just I think if just the last couple of years, just seen there's been a massive drive, obviously around a lot more focus on data quality. I guess obviously you've had the Gen AI boom as well. It's just obviously created all this unstructured data problems for businesses.
Yeah, I would say, the trend started probably, I would say, for 4, 5, 6 years. I think Hadoop started that shift towards combining structured and unstructured data together and leveraging benefit. I feel that was the pivotal moment in this space. Before that, structured and unstructured played in their own space, and nobody ever talked about a lot of connecting them together. And it's also about the advancement of technologies, both on the platform side as well as the capabilities that exist with us, plus a lot of digitization. I think all these things put together has created this opportunity, and it's been a very exciting space.
Yeah. What's your story? Why did you get into technology? Obviously, you're working with one of the big players now in the market as well, who have probably a lot of data. So I mean, what sort of attracted you to this industry?
It's probably not a very exciting story, to be very honest. I have to acknowledge I fell into this space. I fell into tech by design. I fell into the data space by chance, is how I would say. Like I said, I started my career very early at IBM, and there was an opportunity that came in when IBM was getting into the open source database market. Till then, it was mostly mainframe, and there was a new product line that came in, and they were looking for somebody to get into it. And I was pretty early in my career, and I thought it was exciting. a bit of my background, and I also was always interested in the business side. I've done MBA and I have done engineering, so I was always looking for opportunities to combine the two things, and I felt very early that data might be one of the things that might help me get into that space to balance between the two areas. And that's how I got into it. And then things I've stayed in that space have grown into my career. Started as a back-end infrastructure, the traditional roles like DBA that probably dating myself or giving my age
Hmm.
out. These roles are limited now, but I started on the infrastructure side, on the data side, and sort of grew my career from the back end into actually delivering the solutions and applications.
Cool, cool. No, that's good enough. Obviously, yeah. I mean, you mentioned DBA. I mean, obviously, it's evolved and changed, doesn't it?
Yep, exactly. I think this space has transformed so much. And another sort of, maybe I'm digressing a little bit, but interesting story. I use this many times when I'm now going to recruiting events or talking to people. I've seen this transformation that the early days nobody wanted to be in the data space, right? If you think about it, a lot of people initially in my career
Mm,
wanted to be in web development, and then people wanted to be in the mobile development, and we struggled to hire people in the data space. And it's interesting to see how this industry has pivoted. Now everybody wants to work on data, so
yeah,
it's pretty interesting, I think.
yeah, no, definitely. Yeah, so we come across obviously a lot of like obviously juniors. Like, how can I get into the industry? Discussed before, obviously, with the software field, you can create a GitHub, can't you, account and illustrate your skills, but you can't really do it in the data space, can you?
Yeah, I think that I do feel, like Kaggle and stuff like that allow you to, if you're motivated, I
Mm,
do feel you can. It's not that straightforward forward as, doing a GitHub account
yeah.
and building an app, but I do feel that there are enough things out there. Kaggle provides public data sets, etc. Python's very easily accessible.
Mm,
I think a lot of basic com science courses now have started talking about teaching basics of data. SQL has become
mm,
computing. So I feel things have changed. It's changing for the right reasons.
mhm,
Uh, so I do feel opportunities exist if you are motivated. And a lot of folks are motivated to be in this way space, which makes it
mm.
interesting.
Well, you need to be, because it's constantly changing. So it's that obviously you need to, like endless learning. Okay, let's dive into the first question. I guess it's probably a bit more for the non-technical listeners. What is data engineering?
So that's a good question, right? For me, data engineering, I would start off saying in a non-engineering terms, I feel it's the backbone of how do you leverage data into an organization that's motivated to leverage data for that benefit. It's basically a discipline that I would say involves understanding data, designing the systems, and maintaining data. That includes collection, transformation, and also how do you deliver that for consumption, whether it's simple things like for dashboarding to operational insights to ML models, AI models, like whatever your consumption. So thinking about all this ecosystem, how do I bring data in? How do I store it? How do I make it easy for consumption purposes, and providing mechanisms to consume? And as we go through, we'll talk about other aspects. But I feel that sort of is the foundation. If I have to summarize, I feel that data engineering is an art of building like a foundational data ecosystem that enables deriving insights from vast amount of information that exists in companies or outside, and drive business outcomes.
There's a lot that goes, a lot that's involved, really, isn't there? So, I mean, it's sort of, I mean, obviously, it's a big area. So, what's the biggest challenge? What are some of the biggest challenges in this field?
The biggest challenge, I would say, obviously, I think you touched upon in the initial part of the conversation, right? I think the volume, the complexity, the variability of data that exists, I feel provides an overwhelming challenge on dealing with these different kinds of data requires a little bit of different kind of handling. So I think doing that is a challenge. I do feel evolution of cloud and hybrid ecosystems, and those things provide its own challenge in these modern data ecosystems that we are building. Obviously, the fundamental issue in engineering is handling quality and complexity. Like,
Mm.
how do you keep data quality up to date? And there's a little bit of reliance on other parties as in terms of where the data originates, etc. I think so. Managing that quality in end to end, right from the production to actual delivery for some of these capabilities, that's an issue. Infrastructure scalability, technology landscape changing. I think these are other technical challenges that exist. I think a lot of newer things keep newer technologies coming. How do you keep up pace with it?
Mm.
And last, I would say, is governance and compliance. I think, as you probably hear a lot, and a lot of these
Mm.
corporations struggle in terms of staying compliant. How do you manage this data? How do you keep it protected? How do you abide by some of the principles that or regulations that they need to comply by? I think that's also fundamental to engineering challenges. But all these are like well known, well talked about challenges. But when I think about it, from a core challenge, and all these are providing challenges, but the fundamental challenge I feel, which is in today's day and age, speed and agility by which you need to do data engineering so that you're able to enable the business outcomes, because the reliance on these data solutions, the iteration, the adaptability to maintain this business competitive advantage is becoming more and more critical. So I feel all these sort of sum it up. I feel that speed and agility to how to do data engineering the right way, the horizontal or core to all these specific challenges that I talked about.
Yeah, and I've definitely like I see speaking to many leaders. Obviously, data quality is a massive problem. It's come up many times discussing with them. So, what is it? Just do you think it's just because it's so complex? There's so many different applications, tools involved. If is that the is that just is it going to get more and more complex? Do you think as because obviously more and more data is going to be entering, or do you think there's going to be new ways to do? Because everyone's on their own data journey, aren't they? So is it going to get
I, I,
easier
I, I,
or?
I do feel it has gotten easier. I think we have made
Mhm.
advancements in technologies and capabilities. I feel if I think about in last 4 or 5 years, I feel we've made pretty good strides. I think there was a little bit of, I don't want to use the word confusion, but I think it's a little bit of uncertainty and where these ecosystems are going. When things like Hadoop came into the ecosystem, traditional data
Mhm.
warehouses, where do we transition? Some people had this philosophy around, moving to Hadoop and all. Then cloud was into the mix. I feel like that space is settling in. A lot of people are settled on what they want to do in this space from an ecosystem perspective.
Mhm.
Plus the tools and technologies with things like LLMs and coming into the space, I do see that our ability to process and and leverage data is getting easier. So I feel in that sense the ecosystem will get easier. I think what will get complex in my mind is the ask from a business perspective and the various ways in which companies would now be creative about leveraging this for their advantage. I think would make it complex in understanding the
Mhm.
data itself, and how do we enable from an engineering perspective. I see that as a challenge more than the infrastructure.
So what do you mean from being getting access to the data?
Access, understanding. I think as we it's- understanding how this data gets used is very critical when you're engineering solutions.
Mm.
And I think and as the business problems get complex, I think being in pace with it so that you have a lot of tool in your toolbox, right? Figuring
Mm.
out which to use to solve the problem. So the tools are no longer the problem, but picking the right tool is important. And for that, understanding what am I going to do with or what am I enabling becomes a little bit critical, I feel. And I see that a lot of interesting ideas being thrown around to leverage and how do we move the needle on them in speed and with agility, I feel is probably the more bigger challenge than the infrastructure, which I felt 5 years back it was more of an infrastructure challenge. The business challenge was there, but the infrastructure challenge was bigger. I feel that's kind of
Mm.
solved in this
So I
market right now.
guess, so I guess remain to the on to stick to the business objective really, because I spoke to I think it was, another business leader about their data warehouse, and they changed during the implementation. They changed the data platform 4 times, so it's obviously that's going to drag time. So again, the speed
Yeah,
and access to that quality is going to take it. It's just going to be delayed, isn't it? So I guess you need to just remain to your business objective, really.
exactly. I think a lot of these decisions have to be made with business priorities on the forefront. I'm
Mm,
not saying that tech priorities or the engineering excellence should take a back seat, but how do we make progress on these engineering items like a platform change or in context to keeping business objective in mind and making sure the outcomes or the benefits are aligned, and we no longer have the luxury, which probably I've done some of these projects in my past life where we took 6 months or 1 year to do a platform change, right? Because it was a massive change. Like I want to adopt cloud, so next 1 year my team is going to work on cloud adoption. I don't think that's going to fly in today's day and age. I
mm,
think so. The question is going to be how do we continuously iterate and provide business outcome while
mm,
making sure you make some of these changes. And I do also feel like I think which you touched upon is the technology advancement has happened in this space that
mm.
some of these things no longer take weeks and months. I feel that I think that's also there. I think hybrid cloud and hybrid approaches, I think which were not very common. I think but
Yeah,
have now are out there. So that also makes it easier.
yeah, definitely touched on like multi-cloud is massive now because yeah, and even obviously with my job with doing hiring, obviously now you're getting data engineering roles where it's not just Azure or AWS or GCP, it's they want multi-cloud experience now, and obviously it just adds a lot more challenges to obviously skill set's got to be more diverse, and it's obviously there's not a lot of people that will have all that experience because they would have done one flavor or the other.
Exactly. Yep. You're spot on that.
So what I guess obviously with this is previously was the boom was more building data science models, hiring data scientists. Now, why is it engineering or data engineering become such a critical function for business?
I think pretty much most companies, leading companies, have realized that the data is the company's most valuable asset. I do feel
Hmm.
that that realization has happened. A lot of companies have started having data leaders on their boards or high up in the organization. Specialized functions, CDO roles have become very common in organizations. So I feel that realizing that data is the most valuable asset, I think it's being now leveraged to drive pretty much decision at every level, whether you're talking about operational efficiency or you're talking about strategic planning. I think it's become a very critical part of this
Hmm.
conversation. And also companies have started realizing that there is a competitive advantage you could get, or you can get into new businesses or get competitive advantage by leveraging what we have. And all these realizations has resulted in identifying new revenue streams, disrupting entire industries. And some of my work that I've done in Google, Morgan Stanley, otherwise, is a testament how some of the industry leaders are leveraging data to fuel their transformation and growth. And to make all these things happen, data engineering is the foundation. With robust data engineering foundation and infrastructure, organizations are simply able to harness the potential of the data. And that's why I feel this has become a very critical piece for the business.
Just yeah, it just feels like we've definitely felt it in terms of a lot more like hiring going into the data engineering space. So that definitely feels it's a lot more efforts because, like I said, I guess data is the key asset for businesses now. Um, but then also getting that in the right and like the right obviously structure, but then also you need to know what to do with it as well.
Yeah, exactly. And then I think that this is where people in businesses also are trying to get closer. A lot of people talk about empowering businesses to get closer to data leverage. It's no longer that the line between business and tech and data being only on the tech side and is blurring. I think companies who are successful are able to figure out a hybrid way of operating where engineering and the tech side is critical and it's not going away. But how is engineering getting more innovative in bringing business folks in so that they are able to look at data more closely to find these opportunities or ideas or partner with them to try out things in this space to look for competitive advantage or look at new businesses or purely efficiency plays.
Brilliant. So, what's the key components of a successful data engineering framework?
So the foundation for me is like a robust data architecture, like thinking about architecture foundationally end to end is important. And as part of that architecture, you need to think about sourcing the data, or a lot of people call it data ingestion. I think thinking about ingesting data from diverse sources, how do you manage? I think that's an important part of that architecture. Then it's just the processing of it, like storing it and then processing it are two additional components. How do we derive value through that process and store it in a way that makes accessing this information easier and faster, including consumption? The other aspects are publishing, in the sense, how do we make it easy for this information to get consumed in the way you want it to be consumed, because consumption patterns are different. This would things like APIs have become a first class citizen in a data engineering aspect, which
Mm,
was not traditionally the case. Always data was thought about as a warehouse with a report on top of it. I think that paradigm has left. So now think about consumption as reports and self-serve analysis, reports, dashboards, but also ML models running on it. How do you empower those analytical models being built, but also connecting it to operational systems and presenting these insights
mm,
as part of operational journeys. Thinking about that is become important. Then I think there are some foundational capabilities that have also become important part of data engineering that you need to think about is understanding the governance aspect, which includes, for me, loosely quality, security, compliance. I briefly talked about some of these things. So think about these aspects
mm,
foundationally as part of data architecture, because I think is one of the things I've seen many companies don't think about it as part of the initial implementation, and then they try to build bolt-on solutions, which then makes it hard. So I feel that's an important component to be thinking about. And then last aspect is just the operational aspect, right? It's very important now that you're the lifeline of that ecosystem of your business,
mm,
thinking about how to keep that function going. So monitoring and maintenance and that infrastructure has to be thought about. How do we make sure that we keep our information fresh, relevant, and accurate? And how are you going to react to things happen in life? It's not going to be a perfect system, so there are going to be issues.
mm.
But the question is, how do we support and maintain this ecosystem is also equally important. So that's loosely in my mind are things that are part of the
Yeah,
framework.
yeah. So you can see why it's really complex, because there's many components that go into it. I guess even like data privacy and data governance, that's been the big growing field within data engineering, isn't it, over recently?
Definitely. That's why I think it's become like a first class citizen in
Yeah.
that many times. I think we've never thought about it when we're building a data solution. We've never thought about it on day one as part of engineering. Now,
Mm,
any of the talks or any of the data strategies that we build, this is, you know, a first class citizen section that we'll ask. If it's not there, then your architecture is incomplete, in my opinion. So I would always
yeah.
ask for that to be thought out. Same as I feel is the operational aspects. I think you need to think about it as part of the design and not as an after fact.
No, brilliant. Interesting. So, can you explain the process of designing and maintaining a robust data pipeline?
Yeah, I think absolutely designing and maintaining like robust pipelines is and ensuring that you're having a reliable and efficient flow involves a few key steps, right? In my mind, the first one is being very clear about the objective and the requirement, right? What
Mm,
are the business goals? Do we have the information to? There might be a goal, but we don't have the information. Like that prep around understanding goals, understanding the data, and the validity and accuracy, and for deriving that purpose, doing that homework before we even get into the engineering part is a critical first step. And then the standard stuff around once you understand that, doing the transformations and having the transformation things documented and validated, as well as thinking about how the data is going to be consumed is the next second. So the end-to-end requirement flow becomes very important to me as a first
Mm-hmm.
step. Then second, obviously, it depends on where you are in your journey, because is the tools and technologies, like what are we going to use? If it's a net new engineering ecosystem versus an existing ecosystem, you don't do it for everything. If you have a foundation, you're not going to be changing tools and technologies for every new problem that comes in. But I think making sure you have the right tools and technologies in place, or what is missing, becomes the second part of it for me. That that again, I know, touches the extraction part, the processing part, storage part, and orchestration part also. How do all these data pipelines work together? Things like Dexter or Airflow and these kind of technologies, making sure you have that orchestration capability in the ecosystem is important. The next aspects is making sure your architecture supports what you're trying to do. Does the architecture need to change? If you have one, does it need to change? If you don't have one, establish it.
Mm-hmm.
Think about quality and monitoring aspects, that those are important. So this includes basic things like validating the data and making sure it's correct, or having feedback loops to the source systems where it's coming from, to make sure we are working with them to improve the quality. Because in some cases, if you're not the source of this information, I think you can't really change it. So you have to work with the providers to make sure
Mm-hmm.
the information gets corrected at source. So having those monitoring, error handling that I've talked about, I think that's a whole aspect that you need to think about. The other aspects are, as part of delivering this, thinking of testing. That's another thing that I've thought about. Traditionally in software development, we talk a lot about testing, but data
Mm-hmm.
testing has its own flavor. So how do we think about testing? And this includes data quality testing, unit testing, integration testing, as well as user getting users involved. Like a very traditional testing mentality needs to come into this ecosystem now. I think because it's
Mm-hmm.
become so critical, it's not one of those things on the side where you put a report out, you get the feedback, and I'll correct it over a period of time. I think again that's a little bit old school for me in terms of engineering. So bringing and then lastly, another aspect which also comes into the operational aspects, but building some engineering into continuously looking at the consumption pattern and understanding how people are using the data that you build, so that you can proactively optimize the work that you're doing, not wait for users to tell you that there's a problem. So what are some of the instrumentation you can do where you get some of the early signals from how data is getting consumed? And it means making adjustments, whether it's at a platform level or a design level or a data model level. Being proactive about it is also another key aspect in my mind.
Mm-hmm. Well, and then obviously with there's many tools on the market. How do you go about choosing what one's going to be best for your project?
Uh, I I don't. Tools is one part. Is I almost feel that I don't want to say all tools are equal. Most of the leading tools are very close to each other in my mind. It's
Mm-hmm.
it's probably the ecosystem. You have to look at it from an ecosystem perspective, where certain things
Mm-hmm.
play well with certain decisions that you made. So I do feel that while making these decisions, you have some critical components that you feel are game changers for what you are trying to do, and then you build the tool and technologies around it. Is how I think about it. And more importantly, I think putting more effort of thinking about how these things are going to work together, and the actual use of it is more important than the pure tool choice. Right? Tool choice is important. I don't want to make it
Mm-hmm.
sound like tools are not important, but I think the differentiators, identifying what your key capabilities or what is important to you, like top 3 or 4 things that are non-negotiable, then making sure that tool does that for you, and whether that tool fits into your ecosystem, whether you're looking for a tool for quality or whether you're looking for a tool for ingestion. I think fitting it into the ecosystem is a more important thing. I think if you make siloed decisions of these things in vacuum,
Yeah.
that's where you will spend a lot of time engineering things to integrate these things together versus leveraging them to deliver business value.
No, interesting. Because I know it's come up from a lot of people we speak to is obviously choosing the right tools. So yeah, no, not interesting thoughts there. So moving on, obviously you touched on sort of data quality is a key part of the data engineering space. How do you ensure data quality and integrity throughout the data engineering process?
I think it's part of implementing the data solutions. I think some of these things I briefly touched upon, but to keep it a little bit short here, I think it's a multi-layered approach for me. One is like just at the beginning, thinking of things like profiling and making sure the data is what it is that's relevant to solve the business problem you're trying to do. So doing that homework or groundwork right in the beginning is extremely critical in my mind before you even get started, before you even put engineers on it, like making sure that groundwork is done. And whatever you can do early will pay big dividends in my mind in terms of what you could do in the longer term. That's where getting some alignment, even from the requirements or business perspective, getting them on board on what is possible based on the information we have and what would happen, whether it's from a time perspective, quality perspective,
Mm.
etc. I think getting everybody else. So I feel that profiling is a pretty key aspect. Thinking about what you can cleanse and what you can validate, having that clear understanding that this is a data that I could make better in my process versus this is a data that I cannot. Like good examples could be thing like an address or something like that. If you have a good address and if it's a matter of standardization, generating zip codes, which is important to me, if it doesn't come through the source system, can I, derive a zip code for a city and a state? Like those are things I feel are easy, but that if there is foundational things of account type or something that is getting created at source, I cannot derive those at the lower
Mm.
part of the process. So that clarity is important in my mind. When you talk about quality, what can I cleanse or enhance versus what can I only validate for accuracy? That
Yeah.
distinction in my mind becomes important. Being very clear about governance, and governance I'm using it's a very loosely used word, but for me it's being very clear is who is the authority of this information, who has ability to make the calls of what is right or wrong, and I'm not using it like an individual or a system. Like this system is where this data originates, and the owner of the system, the custodians and etc. are very well known. Right, the stewards, custodians are known for this space, and who should you go to for which information? I think thinking about it early is important. And last couple of things is making it easy to track the lineage, right? How this information is flowing from left to typical architectural pattern for consumption. Keeping track of this movement and what is happening, what is transforming, what is getting aggregated, what is getting filtered out. The more you can capture, I think the answer to be able to answer the accuracy and quality will become easier in my mind. And last, I think I briefly talked about this whole big into operational aspects of these solutions, right? Are you proactively monitoring? Do you have enough instrumentation to support and keep these pipelines? I think it's equally critical because half your pipelines will run, half don't run. You published one table with all the active transactions, but you've not published your customer table, and you don't have the customers where transaction. You've not. Like, this is a very basic example, but
Mhm.
those kind of integrity checks are very important. And operationally, you can make sure what you're publishing as a whole is complete.
Mm. And then what tools do you find are essential for data engineering?
I'll connect it back to a couple of questions
Mm.
back in terms of capabilities we talked about, right? Like in terms of platform is important. I think you
Yeah.
make a decision on a platform whether you're going to go 100% cloud, hybrid, whether you're going to go to
Okay.
GCP, AWS, Azure, or something else. I think that becomes an important thing. data pipelines, processing technologies, or some folks call it ETL, ELT technologies. I think that space is important. There are a lot of top players out there in that space. Getting that
Hmm.
strategy right, it doesn't have to be one thing only. You could potentially mix and match, but being very clear of what you use when is important. Data processing is important. I think we talked about the variety and
Hmm.
volume of data. So how do you process in a short amount of time in terms of scale, etc., becomes important. Then obviously your store becomes important, whether you're looking for a columnar store or looking at products like BigQuery or Snowflake, those kind of things, or you're looking for some other type of storage technologies. That's important. Orchestration I talked about. I always feel
Hmm.
orchestrating this workflow is important. I talked about monitoring. I think looking at what tools will allow me to do the monitoring that I've been harping upon for last two questions, right? So what are those capabilities? And last, which I also talked about, is consumption side. What do I need to make consumption, whether it's the catalog, whether it's the dashboarding tools, or whether making it easy for self-serve users to consume, or analytic ecosystem, like
Hmm.
how they run models on it. So those are, I think,
Yeah,
important.
nice shopping list for a business.
And vendors too, right?
So obviously, customer house, you got that set up. I mean, what strategies would you employ to ensure data infrastructure can scale with growing data volumes?
So obviously the foundation is the scalable architecture that you
Hmm.
establish. Like when you're establishing the foundation, thinking about it, how would I grow or shrink this to keep it cost effective with changing time, which is where things like cloud technologies are getting very popular, because it allows you to not have these massive projects in terms of scaling. I've run projects where we had to add servers into our ecosystem to scale, and that's like a multi-month planning project and execution pretty quickly. And those are large projects. I think thinking about that is important. I feel like from an infrastructure perspective, thinking about coming down a little bit more lower level is thinking about partitioning things like sharding, partitioning, thinking of your engineering solutions, your processing, your data, like thinking about it as smaller, manageable units that you can scale more easily versus one monolithic thing that becomes very hard to scale. So the design part of it becomes very important when you're uh, thinking about infrastructure. The design aspect of that becomes important. Thinking of data as smaller chunks is important. Thinking about caching technologies is important. There are things that
Hmm.
you probably access more frequently than others, which is where it goes back to one of my points around understanding the access pattern is important, because once you access and you understand that this is what 99% of my users always access this information, then I can think from an infrastructure perspective, how can I make that
Hmm.
access more easy? Can I introduce a caching technology, or something like that sort of plays into that space? So that's part of the scalability aspects. Load balancing, or balancing the work across, like thinking about the infrastructure that you have, how can you load balance the work, actually grow horizontally where it makes sense, or vertically in some cases if
Hmm.
processing is more important. So that's important. And then just the foundations, right, is are understanding the foundations are still there in terms of understanding the query, optimizing the query, understanding the data access pattern. That's not gone away, right? There are a lot of tools and technologies that make it easy, but that fundamental understanding of ultimately how that query is going to run and how can I optimize it is still relevant in my space,
Yeah.
in my mind, in terms of skills.
Okay. Interesting. And then moving on to the next question. So, how does data engineering play a role in ensuring compliance and security?
Great question, right? I think it's become data engineering has become very crucial, eh, and it should be the first tenet of any of the designs and implementations that we do. That we have to think about what data I am getting, understanding tagging this data for the right level of sensitivity becomes important. That should become part of data engineering now. And then are we doing the right things in terms of things like encryption, auditing, in terms of access, right? Security. What are the who can see what? I think these things are should be inbuilt as part of the data engineering function when you're designing things. Again, I think a lot of these things are thought about afterwards or as an after fact. That
Mm-hmm.
makes implementations a lot harder. I think mature organizations that are doing well in this space think about this as part of the original architecture design is being built. Like, it's a non-negotiable thing, like GDPR or CCPA. These are requiring you to delete data in some cases, anonymize data in some cases, enable lineage tracking in other cases, right? These are become very foundational in nature. So data engineers to need to be thinking of all these things: access control, encryption, anonymization, masking, auditing. I think these are fundamental things that every data engineer should be thinking of into their solution.
And then, can you share an example of how data engineering has delivered like significant business value?
There are a lot of examples where there are successfully engineered data solutions that are being talked out. If you search, you'll find things around personalized experiences or improving customer satisfaction, driving revenue growth. But for me, as a data engineering leader, I feel the value is exponential when you are able to engineer a foundation that enables business a multiple business outcomes. So you're building a foundation that's not meant for a certain purpose or a certain goal. You might start with a one purpose or one goal to be achieved, but you're
Mm-hmm.
actually thinking smartly around engineering it so that then when the second problem comes, third problem comes, you're able to build off it and accelerate the delivery. So there I've led some examples around engineering things like relationship 360 foundations, where we've been able to successfully understand in a large multi-business corporation how a complex partner relationships across financials, contracts, etc. is well understood. The same platform, when we engineered it, became very easy for us to extend to enabling the sales and purchasing teams to make business driven decisions around business growth and cost optimization. At the same time, it became a simple ad hoc business query to understand exposure of a certain partner across our company. If you do it right, I think it multiplies and gives you value in the later part. I think that's for me as a value from a data engineering
Mm-hmm.
function perspective. Each one of these business cases are adding value, but as a data engineering leader, for me, the value is that I build something foundationally that is multiplying.
Nice, interesting thoughts. Well, I mean, what's the emerging trends in data engineering that businesses should be wary of?
Yeah, obviously, the first thing that a lot of people will probably pick up on is how is LLMs going to
The
introduce. So I
hot
think that's
topic.
very hot topic. But I'll probably stay a little bit more traditional on this and think about from my vantage point. And again, not saying that LLMs are relevant, very relevant, but I think I feel when you ask me what are the trends that I always keep a pulse on how they are improving or getting better, or newer things are getting introduced. And LLMs may play a part in actually some of these things. But for me, these trends are the speed at which you process data, right? In a lot of real time processing, near real time. Like, I think that whole space about how you're able to do it very efficiently, I think it's expensive to build these
Mm-hmm.
kind of things, keep it running and keep it accurate. So whatever trends are in that space, I think are super relevant in terms of how you could do that, is important. I do personally feel cloud native engineering provides the scale, flexibility, and effectiveness in
Mm-hmm.
terms of what we want to do. So what's happening in that space, and being smart about not lock. I think you talked about it. Nobody wants to lock into one vendor and being flexible. So how do you think about that space? But at the same time, I think there's a significant value in terms of what a cloud-like platform offers in terms of scale. So that's an interesting thing. Other things that I always the architecture patterns, keeping in keeping an eye on various patterns that are developing. And in today's, like right now, I would say something like a data mesh architecture is pretty relevant, which allows you to break the silos and empower each teams to make progress, improving the thing that I talked about, like agility and business alignment. I feel that whole space is interesting. There are slight variations of how that can be implemented, but I think that space, the whole architecture space, is important. Again, unless you're living under a rock, how AI, ML, our first class citizens in this
Mm,
space are important. I think it's from automation, whether it's things like data quality cleansing, pipeline automation. I think all these things are getting very much influenced by this technology. So being there, other emerging trend is around data observability. I think thinking about this is where again ties into the reliability quality aspects, right? Being able to provide end-to-end visibility of data from pipeline perspective, tracking lineage, quality metrics. I think that space is interesting. I think LLMs will somehow, I think, already push the needle on no code data engineering. I think
mm,
auto generated code, I think that's important. Ethics and responsible AI also is important. That sort of space into the foundational aspects that you need to
mm,
sort of stay very, very close to. And obviously, anything in a governance security space, I would say, is
yeah,
again non-negotiable.
yeah. There's lots to be lots to be discussed across the business.
Yeah, it's a lot, and but anyway, I strongly feel by staying ahead in these trends, the business can leverage the power of data engineering to drive
Mm,
innovation, gain advantage, and make more informed decisions. I think it's pretty critical and in many cases
mm.
non-negotiable that you can be left behind in this space.
Yeah, no, definitely. Cool. Nice, good insights. And then just to obviously, the data market is obviously wants more people, it wants more talent. Obviously, for the junior listeners, what the, and for listeners, want to pursue a career in data engineering, what's the key skills and qualifications they should develop, learn? Because obviously, it's evolving.
Yeah, definitely. I think it's an interesting phase. Obviously, I think the first thing I would say is not again not discouraging people, but I think you need to have passion. I think there's a certain passion for
Mm,
data that you need to have, and if it's an area for you, then the skills that I would tend to invest in is the and it's become more and more relevant and important now in this today's day and age in the ecosystem is the foundations of programming. I think you need to understand basics of programming and how to build, right?
mm,
You don't have to be the expert coder, but the foundations of writing good code, I think, is important because things like Python, Java, Scala becomes like first class citizen in this space, right? So knowing that is important, I feel. So foundational in programming. SQL, non-negotiable. I think you need to understand SQL,
mm,
not just
mm,
writing simple SQL, like how does SQL work and being able to efficiently. A lot of tools will generate SQL for you, write SQL for you, but if you don't understand the 101 of it, I think you can be a very good engineer in this space, is how I
mm,
personally believe. Um, learn about data architecture, learn about things like data modeling, which are very foundational to engineering advice, right? If you
mhm,
understand how you're going to structure the data, that's like such a key aspect of being successful. Infrastructure, we loosely talked about a lot of tool technology. In fact, I think the whole
mhm,
cloud platforms are infrastructure foundational. I don't feel you need to be a master in it, but you need to understand this space and
mm,
understand the components relatively well if you want to be successful or grow. This is
mm,
especially if you want to grow further, not just get in. I think it probably may not be as relevant on day one when you get in. Data pipeline tools, technologies tend to stay relevant. So I would say that pay attention to those and just basic com science, right? Basic com science is still relevant. I know things that
yeah.
studied go still stay relevant. Tools, technologies come, but the fundamentals never change. So those fundamentals of programming and that are taught in school, I think studying com science, I feel as well, pursuing some form of com science courses, whether that's your major or not, is secondary. Learning that and then building on these skills is the right way to bring in. And then obviously the soft skills around communication, problem solving, and adaptability are crucial.
Mm,
Last, I would say, I believe for a data engineer to be successful, you develop all these skills and capabilities. But the more important thing, which is where I started, I feel the most important thing is you need to have passion for the data domain, right? You have to have passion to work with data problems, and to complement it, you need to understand the business. what are you trying to do is such a core aspect to being a successful data engineer, right? If you don't understand the business outcome or what that business capability is, you tend to end up building solutions that are either too complex, too siloed, or sometimes just take too long to build. So I feel that's always mentor a few people, and I always encourage them that we are in that world where unless you're going into very deep com science problems where you're building com science, and that there's a space for that. But if you're using data for a business benefit, learning business or domains is equally important. Just pay some
Mm.
attention to.
Yeah, no, obviously, yeah. Passion does. If you love what you work, you're gonna just put that extra oomph, aren't you? In. But so obviously, yeah, interesting point you made about the domains because data engineering is quite a techie area. Do you think it's going to evolve into more? Say it's a financial services company, you need data engineering skills and the financial services domain expertise. Do you think it's going to evolve like that? Because data is getting more like more together with the business, isn't it? So do you
A
think to
hundred
have that
percent.
knowledge?
I 100% feel it's already there. I think
Yeah.
successful companies, the companies that I've worked on in financial services already have blurred that line between
Mm,
business and technology. Technologists getting hired on the business side, business folks getting hired on the technology side, and it's really
mm,
the successful companies figure out how to break that wall between you write the BRD, you ship it over, engineering will do design, and
mm,
I think it's the partnership. The successful projects have all these folks in one team. And so
mm,
if you are coming still from an engineering perspective, being able to work with somebody who comes with a strong business background, being able to even communicate and explain certain concepts and understand their concepts becomes very relevant. So you'll be successful
mm,
if you're able to almost communicate. You don't have to be the financial expert, but I think some fundamental understanding of some fundamental concepts, financial
mm,
services become interesting. The other I would say is there's so much disruption going on, right? I think this is where I say there are combination of skills that probably traditionally we've never thought about one person following pursuing. Can you think of a com science guy and somebody doing something in the medical field, or a com science guy and a lawyer? I think
mm,
these are never like talked about in the same sentence. But if you think about the amount of disruption that's happening in the health industry, or disruption that probably happens in the legal space, people who are going to be successful need to understand both sides, right? To even come up with a technical engineering solution. If
mm,
you don't know the business problem or what's possible, you're going to struggle. So again, those are going to be far and few where they're experts on both sides. But for you to be
mm.
successful, you need to be able to you need to be able to communicate and understand some of these
Yeah.
terms and technologies. And so spend some time. You don't want to scare people saying you have to get experts in all these areas. But I think being passionate about, if you hear a term from a business, ask the question. Or that tools like Ask Gemini or something like that. What is it? Like you have so much
Mm,
tools, be curious and learn and build that knowledge base.
mm. No, brilliant, cool. Good insights there. Because obviously, I've seen it with the, especially like data scientist roles we've had in the insurance sector. Like they're now not just like techie data scientists. They want
Mhm.
the product experience, the insurance domain, the actuary knowledge. It's all like getting more into the business side of things. So it's good insights you shared on data
Yeah.
engineering because that's quite techie. But obviously, that's seems like it will be more evolve into that type of work as well, like getting more domain focused.
Because I think you can architect and engineer things better if you understand what these
Yeah.
data scientists are going to do. I talked about understanding the access patterns, or what if upfront, what is this critical within that domain, what are these critical entities that I want to, that when I do the model, when I do the engineering, I would do a much better job versus I treat all of this. So that's where I think it helps. I think it has, you grow over a period of time, but people want to grow in this career, being in India. I think, like I said, I don't want to say that's like the thing to get into the
Mm,
field. I think some of the basics are enough, but to grow into this field, this is going to
mm.
be extremely important in my mind.
Brilliant. Cool. Well, that's brilliant to have you on the podcast, and you've shared some great information and some brilliant insights for the audience.
Oh, I appreciate Ben for having me. I enjoyed this conversation as well, and uh, look forward to how the feedback goes.
Brilliant. Thanks for your time.
Take care, Ben. Thank you.